Margaret Thatcher became the first world leader to warn about the dangers of global warming.
The danger of global warming is as yet unseen, but real enough for us to make changes and sacrifices so that we do not live at the expense of future generations.
Margaret Thatcher was uniquely qualified among world leaders to evaluate the science of climate, with a chemistry degree from Oxford and experience as a researcher. She may have been aware of how advanced military programs on heat-seeking missiles clearly detailed the physics of the greenhouse effect as early as the 1950s, and that a high-level scientific panel wrote to President Johnson in 1965, warning that man is unwittingly conducting a vast geophysical experiment with greenhouse gases. She may have read the scientific journals in the 1970s that warned of emerging global warming, or heard the words of leading researchers in the field.
Scientific consensus that CO2 will build up and will be a potential problem is very large.
She was probably aware of the U.S. National Academy of Science assessment in 1979 that affirmed the science and warned that a wait-and-see attitude on climate change might mean waiting until it was too late. Certainly she wouldn't have missed the many news reports on the issue.
Researchers say increasingly large amounts of CO2 are accumulating in the atmosphere. They fear the Earth will gradually become warmer, causing as yet uncertain but possibly disruptive changes in the Earth's climate.
In the sweltering summer of 1988, almost everyone noticed when a senior NASA scientist, James Hansen, came before a congressional panel with a statement that seems more than prescient today.
The greenhouse effect has been detected, and it is changing our climate now.
Mr. President, it gives me great pleasure to return to the podium of this Assembly. When I last spoke here 4 years ago, on the 40th anniversary of the United Nations, the message that I and others like me gave was one of encouragement to the organization to play the great role allotted to it. Of all the challenges faced by the world community in those 4 years, one has grown clearer than any other in both urgency and importance. I refer to the threat to our global environment. The threat of global annihilation, the fact of regional war, appear to be receding. We have all recently become aware of another insidious danger. It is as menacing in its way as those more accustomed perils with which international diplomacy has concerned itself for centuries. It is the prospect of irretrievable damage to the atmosphere, to the oceans, to Earth itself. Of course, major changes in the Earth's climate and environment have taken place in earlier centuries when the world's population was a fraction of its present size. The causes are to be found in nature itself, changes in the Earth's orbit, changes in the amount of radiation given off by the sun, the consequential effects on the plankton in the ocean, and in volcanic processes. All these we can observe, and some we may be able to predict, but we don't have the power to prevent or control them. What we are now doing to the world, by degrading the land surfaces, by polluting the waters, and by adding greenhouse gases to the air at an unprecedented rate, all this is new in the experience of the Earth. It is mankind and his activities which are changing the environment of our planet in damaging and dangerous ways. We can find examples in the past. Indeed, we may well conclude that it was the silting up of the river Euphrates which drove man out of the Garden of Eden. We also have the example of the tragedy of Easter Island, where people arrived by boat to find a primeval forest. In time, the population increased to over 9,000 souls, and the demand placed upon the environment resulted in its eventual destruction as people cut down the trees. This in turn led to warfare over the scarce remaining resources, and the population crashed to a few hundred people without even enough wood to make boats to escape. The difference now is in the scale of the damage we are doing. We are seeing a vast increase in the amount of carbon dioxide reaching the atmosphere. The annual increase is 3 billion tons, and half the carbon emitted since the Industrial Revolution still remains in the atmosphere. At the same time as this is happening, we are seeing the destruction on a vast scale of tropical forests, which are uniquely able to remove carbon dioxide from the air. Every year, an area of forest equal to the whole surface of the United Kingdom is destroyed. At present rates of clearance, we shall by the year 2000 have removed 65% of forests in the humid tropical zones. The consequences of this become clearer when one remembers that tropical forests fix more than 10 times as much carbon as do forests in the temperate zones. We now know, too, that great damage is being done to the ozone layer by the production of halons and chlorofluorocarbons. But at least we have recognized that reducing and eventually stopping the emission of CFCs is one positive thing we can do about the menacing accumulation of greenhouse gases. It is, of course, true that none of us would be here but for the greenhouse effect. It gives us the moist atmosphere which sustains life on Earth. We need the greenhouse effect, but only in the right proportions. More than anything, our environment is threatened by the sheer numbers of people and the plants and animals which go with them. When I was born, the world's population was some 2 billion people. My grandson will grow up in a world of more than 6 billion people. Put in its bluntest form, the main threat to our environment is more and more people and their activities, the land they cultivate ever more intensively, the forests they cut down and burn, the mountainsides they lay bare, the fossil fuels they burn, the rivers and the seas they pollute. The result is that change in future is likely to be more fundamental and more widespread than anything we have known hitherto. Change to the sea around us, change to the atmosphere above, leading in turn to change in the world's climate, which could alter the way we live in the most fundamental way of all. That prospect is a new factor in human affairs. It's comparable in its implications to the discovery of how to split the atom. Indeed, its results could be even more far-reaching. We're constantly learning more about these changes affecting our environment, and scientists from the Polar Institute in Cambridge and the British Antarctic Survey have been at the leading edge of research in both the Arctic and the Antarctic, warning us of the greater dangers that lie ahead. Let me quote from a letter that I received only 2 weeks ago from a British scientist on board a ship in the Antarctic Ocean. He wrote, "In the polar regions today, we are seeing what may be early signs of man-induced climatic change. Data coming in from Halley Bay and from instruments aboard the ship on which I am sailing show that we are entering a spring ozone depletion, which is as deep as, if not deeper, than the depletion in the worst year to date. It completely reverses the recovery observed in 1988. The lowest recording aboard this ship is only 150 Dobson units for ozone total content during September, compared with 300 for the same season in a normal year. That, of course, is a very severe depletion. He also reports on a significant thinning of the sea ice. And he writes that in the Antarctic, he says, our data confirm that the first-year ice, which forms the bulk of sea ice cover, is remarkably thin, and so is probably unable to sustain significant atmospheric warming without melting. Sea ice, he continues, separates the ocean from the atmosphere over an area of more than 30 million square kilometers. It reflects most of the solar radiation falling on it, helping to cool the Earth's surface. If this area were reduced, the warming of Earth would be accelerated due to the extra absorption of radiation by the ocean. The lesson of these polar processes, he goes on, is that an environmental or climatic change produced by man may take on a self-sustaining or runaway quality and may be irreversible. That is from the scientists who are doing work on the ship that is at present considering these matters. These are sobering indications of what may happen, and they led my correspondent to put forward the interesting idea of a World Polar Watch, amongst other initiatives, which will observe the world's climate system and allow us to understand how it works. We also have new scientific evidence from an entirely different area, the tropical forests. Through their capacity to evaporate vast volumes of water vapor and of gases and particles which assist the formation of clouds, the forests serve to keep their regions cool and moist by weaving a sunshade of white reflecting clouds and by bringing the rain that sustains them. A recent study by our British Meteorological Office on the Amazon rainforest shows that large-scale deforestation may reduce rainfall and thus affect the climate directly. Past experience shows us that without trees there is no rain, and without rain there are no trees. Mr. President, the evidence is there. The damage is being done. What do we, the international community, do about it? In some areas, the action required is primarily for individual nations or groups of nations to take. I'm thinking, for example, of action to deal with the pollution of rivers. And many of us now see the fish back in rivers from which they had disappeared. I'm thinking of action to improve agricultural methods, good husbandry which ploughs back nourishment to the soil, rather than the cut and burn, which has damaged and degraded so much land in some parts of the world. And I'm thinking of the use of nuclear power, which, despite the attitude of so-called Greens, is the most environmentally safe form of energy. But the problem of global climate change is one that affects us all, and action will only be effective if it's taken at the international level. It's no good squabbling over who is responsible or who should pay. Whole areas of our planet could be subject to drought and starvation if the pattern of rains and monsoons were to change as a result of the destruction of forests and the accumulation of greenhouse gases. We have to look forward, not backward. And we shall only succeed in dealing with the problems through a vast international cooperative effort. Before we act, we need the best possible scientific assessment. Otherwise, we risk making matters worse. We must use science to cast a light ahead so that we can move step by step in the right direction. The United Kingdom has agreed to take on the task of coordinating such an assessment within the Intergovernmental Panel on Climate Change, an assessment which will be available to everyone by the time of the second World Climate Conference next year. But that will take us only so far. The report will not be able to tell us where the hurricanes will be striking, who will be flooded, or how often and severe the droughts will be. Yet we'll need to know these things if we are to adapt to future climate change. And that means we must expand our capacity to model and predict climate change. We can test our skills and methods by seeing whether they would have successfully predicted past climate change for which historical records exist. Britain has some of the leading experts in this field, and I'm pleased to be able to tell you that the United Kingdom will be establishing a new centre for the prediction of climate change, which will lead the effort to improve our prophetic capacity. It will also provide the advanced computing facilities that scientists need, and it will be open to experts from all over the world, especially from the developing countries, who can come to the United Kingdom and contribute to this vital work. But as well as the science, we need to get the economics right. That means, first, we must have continued economic growth in order to generate the wealth required to pay for the protection of the environment. But it must be growth which doesn't plunder the planet today and leave our children to deal with the consequences tomorrow. And second, we must resist the simplistic tendency to blame modern multinational industry for the damage which is being done to the environment. Far from being the villains, it is on them that we rely to do the research and find the solutions. It's industry which will develop safe alternative chemicals for refrigerators and air conditioning. It's industry which will devise biodegradable plastics. It's industry which will find the means to treat pollutants and make nuclear waste safe. And many companies, as you know, already have massive research programs. The multinationals have to take the long view. There will be no profit or satisfaction for anyone if pollution continues to destroy our planet. As people's consciousness of environmental needs rises, they're turning increasingly to ozone-friendly and other environmentally safe products. The market itself acts as a corrective. The new products sell, and those which caused environmental damage are disappearing from our shelves. And by making these new products widely available, industry will make it possible for developing countries to avoid many of the mistakes which we older industrialized countries have made. We should always remember that free markets are a means to an end. They would defeat their object if, by their output, they did more damage to the quality of life through pollution than the well-being they achieve by the production of goods and services. On the basis, then, of sound science and sound economics, we need to build a strong framework for international action. It's not new institutions that we need. Rather, we need to strengthen and improve those which already exist. In particular, the World Meteorological Organization and the United Nations Environment Programme. The United Kingdom has recently more than doubled its contribution to UNEP, and we urge others who have not done so and who can afford it to do the same. And the central organs of the United Nations, like this General Assembly, must also be seized of a problem which reaches into virtually all aspects of their work and will do so still more in the future. The most pressing task which faces us at the international level is to negotiate a framework convention on climate change, a sort of good conduct guide for all nations. Fortunately, we have a model in the action already taken to protect the ozone layer. The Vienna Convention in 1985 and the Montreal Protocol in 1987 established landmarks in international law. They aim to prevent, rather than just cure, a global environmental problem. I believe we should aim to have a convention on global climate change ready by the time the World Conference on Environment and Development meets in 1992. That will be among the most important conferences the United Nations has ever held. I hope that we shall all accept a responsibility to meet this timetable. The 1992 conference is indeed already being discussed among many countries in many places. And I draw particular attention to the very valuable discussion that members of the Commonwealth had under the Prime Minister of Malaysia's chairmanship at our recent Commonwealth Heads of Government meeting in Kuala Lumpur. But a framework isn't enough. It will need to be filled out with specific undertakings, or protocols in diplomatic language, on the different aspects of climate change. These protocols must be binding, and there must be effective regimes to supervise and monitor their application. Otherwise, those nations which accept and abide by environmental agreements, thus adding to their industrial costs, will lose out competitively to those who do not. The negotiation of some of these protocols will undoubtedly be difficult, and no issue will be more contentious than the need to control emissions of carbon dioxide, the major contributor, apart from water vapor, to the greenhouse effect. We can't just do nothing, but the measures we take must be based on sound scientific analysis of the effect of the different gases and the ways in which these can be reduced. In the past, there's been a tendency to solve one problem at the expense of making others worse. The United Kingdom therefore proposes that we prolong the role of the Intergovernmental Panel on Climate Change after it submits its report next year, so that it can provide an authoritative scientific base for the negotiation of this and other protocols. We can then agree to targets to reduce the greenhouse gases and how much individual countries should contribute to their achievement. We think it important that this should be done in a way which enables all our economies to continue to grow and develop. The challenge for our negotiators on matters like this is as great as for any disarmament treaty. The Intergovernmental Panel's work must remain on target, and we must not allow ourselves to be diverted into fruitless and divisive arguments. Time is too short for that. Before leaving the area where international action is needed, I would make a plea for a further global convention, one to serve and to conserve the infinite variety of species of plant and animal life which inhabit our planet. The tropical forests contain a half of the species in the world, so their disappearance is doubly damaging. And it is astonishing but true that our civilization, whose imagination has reached the boundaries of the universe, doesn't know to within a factor of 10 how many species the Earth supports. What we do know is that we're losing them at a reckless rate, between 3 and 50 each day on some estimates, species which could perhaps be helping us to advance the frontiers of medical science. We should act together to conserve this precious heritage. Every nation will need to make its contribution to the world effort, so I want to tell you how Britain intends to contribute, either by improving our own national performance in protecting the environment, or through the help that we give to others. And I shall tell you under 4 headings. First, we shall be introducing over the coming months a comprehensive system of pollution control to deal with all kinds of industrial pollution, whether to air, water, or land. We're encouraging British industry to develop new technologies to clean up the environment and minimize the amount of waste it produces, and we aim to recycle 50% of our household waste by the end of the century. Secondly, we shall be drawing up over the coming year our own environmental agenda for the decade ahead. That will cover energy, transport, agriculture, industry, everything which affects the environment. With regard to energy, we already have a £2 billion programme of improvements to reduce acid rain emissions from our power stations. We should be looking more closely at the role of non-fossil fuel sources, including nuclear, in generating energy, and our latest legislation requires companies which supply electricity positively to promote energy efficiency. On transport, we shall look for ways to strengthen controls over vehicle emissions and to develop the lean burn engine, which offers a far better long-term solution than the three-way catalyst in terms of carbon dioxide and the greenhouse effect. We've already reduced the tax on lead-free petrol to encourage its use. That's an example of using market-based incentives to promote good environmental practice, and we shall see whether there are other areas where this same principle can be applied. And with regard to agriculture, we recognize that farmers not only produce food, which they do with great efficiency, they need to conserve the beauty of the priceless heritage of our countryside. So we're therefore encouraging them to reduce the intensity of their methods and to conserve wildlife habitats. We're planting new woods and forests. Indeed, there's been a 50% increase in tree planting in Britain in the last 10 years. We also aim to reduce chemical inputs to the soil, and we're bringing forward measures to deal with the complex problem of nitrates in water. All that is part of our own 10-year program coming up to the end of this century. And third, we're increasing our investment in research into global environmental problems. I've already mentioned the Climate Change Centre that we are establishing. In addition, we're supporting our own scientists, and in particular the British Antarctic Survey's crucial contribution to the World Ocean Circulation Experiment, as well as the voyages of our aptly named research ship, the Charles Darwin. We've also provided more money for the climate and environment satellite monitoring programs of the European Space Agency. And fourth, we help poorer countries cope with their environmental problems through our aid program. We shall give special help to manage and preserve the tropical forests. We are already assisting in 20 countries and have recently signed agreements with India and Brazil. And as a new pledge, I can announce today that we aim to commit a further £100 million bilaterally to tropical forestry activities over the next 3 years, mostly within the framework of the Tropical Forestry Action Plan. That is all what we are doing in Britain under those 4 headings, all of those things. Mr. President, the environmental challenge which confronts the whole world demands an equivalent response from the whole world. Every country will be affected, and no one can opt out. We should work through this great organization and its agencies to secure worldwide agreements on ways to cope with the effects of climate change, the thinning of the ozone layer, and the loss of precious species. We need a realistic program of action and an equally realistic timetable. Each country has to contribute, and those countries who are industrialized must contribute more to help those who are not. The work ahead will be long and exacting. We should embark on it hopeful of success, not fearful of failure. I began with Charles Darwin and his work on the theory of evolution and the origin of species. Darwin's voyages were among the high points of scientific discovery. They were undertaken at a time when men and women felt growing confidence that we could not only understand the natural world, but we could master it too. Today, we've learned rather more humility and respect for the balance of nature. But another of the beliefs of Darwin's era should help to see us through: the belief in reason and the scientific method. Reason is humanity's special gift. It allows us to understand the structure of the nucleus. It enables us to explore the heavens. It helps us to conquer disease. Now we must use our reason to find a way in which we can live with nature and not dominate nature. At the end of a book which has helped many young people to shape their own sense of stewardship for our planet, its American author quotes one of our greatest English poems, Milton's Paradise Lost. When Adam, in that poem, asks about the movements of the heavens, Raphael the archangel refuses to answer. Let it speak, he says, the Maker's high magnificence, who built so spacious, and his line stretched out so far, that man may know he dwells not in his own, an edifice too large for him to fill, lodged in a small partition, and the rest ordained for uses to his Lord best known. We need our reason to teach us today that we are not, that we must not try to be, lords of all we survey. We are not the lords. We are the Lord's creatures, the trustees of this planet, charged today with preserving life itself, preserving life with all its mystery and all its wonder. May we all be equal to that task. Thank you, Mr. President.
No generation has a freehold on this earth. All we have is a life tenancy with a full repairing lease.
Okay, you just heard Margaret Thatcher giving a speech about global warming in 1989 before the United Nations, and that was about a half-hour speech. So that was 1989. Margaret Thatcher thought that global warming was a big, huge problem and that the entire world, the international community, should move to take action to solve the problem. And Margaret Thatcher is a conservative from Great Britain. So the idea that Al Gore cooked this whole thing up or George Soros cooked the whole thing up, no. Margaret Thatcher, conservative from Great Britain, already was worried about it. She is a chemist, by the way, or was a chemist. So I thought I would do for the second part of this video is to read from the American media. So I'm directing my comments mostly at conservative people who don't believe this stuff. And that would include WBCK and the Tea Party and the Republican Party who think it's a hoax, just like Donald Trump. They're as stupid as Donald Trump is on this. So I go to the American Meteorological Society, which are the weather people. They do the weather forecasts. Every day they do weather forecasts. You know, temperature and cloudy, rainy, sunny, whatever. So they have here a statement on climate change, information statement on the American Meteorological, adopted in 2012. And it's a long statement. I don't know if I can go through the whole thing. But let's see. Let me start. It says background. Let me move it. Okay, they start out with, here they mention in background, International Panel on Climate Change, U.S. National Academy of Science, U.S. Global Change Research Program. Okay, these are some of the groups they're affiliated with. Okay, and then it goes into, okay, how is the climate changing? Okay, so is the first argument from the conservatives is it isn't getting hotter. The whole planet isn't warming up. The sea levels are not rising. The ice is not melting. The glaciers aren't melting. The polar ice cap isn't melting. No, all those are true. The sea level is rising. The glaciers are melting. The polar ice cap is shrinking. Temperatures are getting hotter. We have a drought in the West right now. This is what, a year-long drought. I don't know, or maybe it's 2 years at this point. So it says the warming of the climate system is now unequivocal, according to many different kinds of evidence. Observation shows increases in global averaged air and ocean temperatures. It's not just the air that's getting warmer, the oceans are getting warmer. As well as widespread melting of snow and ice and rising globally average sea level. Surface temperature data for Earth as a whole, including readings over both land and ocean, show an increase of about 0.8 degrees C, that's Celsius, 1.4 degrees Fahrenheit, F, over the period 1901 to 2010, and 0.5 degrees C, or 0.9 degrees Fahrenheit, over the period of 1979 to 2010, the era which satellite-based temperature data are routinely available. Due to natural variability, not every year is warmer than the preceding year. In other words, it doesn't go up every year. Nevertheless, all of the 10 warmest years in the global temperature records up to 2011 have occurred since 1997, with 2005 and 2010 being the warmest 2 years in more than a century of global records. The warming trend is the greatest in the northern latitudes and over land. In the U.S., most of the observed warming has occurred in the West and Alaska. For the nation as a whole, there has been twice as many record daily high temperatures as record daily low temperatures in the first decade, of the 21st century, meaning 2000 to 2010. The effects of this warming are especially evident in the planet's polar region. Arctic ice extent and volume have been decreasing for the past several decades, both in Greenland and Antarctic ice sheets have lost significant amounts of ice. Most of the world's glaciers are in retreat. So the ice is melting everywhere. Other changes globally and in the U.S. are also occurring at this time. The amount of rain falling in very heavy precipitation events, the heaviest 1% of all precipitation event has increased over the last 50 years throughout the U.S. Freezing levels are rising in elevation. Okay, so that means that it's getting warmer at lower levels, or it's starting to get warmer, and the warm is going up in elevation. If you go higher you go, it gets colder. If you climb a mountain, it's colder at the top than it is at the bottom. So freezing levels, it's getting warmer in higher elevations, with rain occurring more frequently instead of snow at mid elevations in the western mountains. That's part of what causes the drought. Spring maximum snowpack is decreasing. Snowmelt occurs earlier. Spring runoff that supplies over 2/3 of the western streamflow is reduced. Evidence of warming is also observed in seasonal changes across many areas, including earlier springs, longer frost-free periods, longer growing seasons, and shifts in natural habitat of migratory patterns of birds and insects. There's so much evidence now, it's overwhelming. So it's happening now. Global average sea level has risen about 17 cubic centimeters, or 17 centimeters, 7 inches in the 20th century, with the rise accelerating since the 1990s. Close to half of the sea level rise observed since the 1970s has been caused by water expansion, meaning water, as the ocean water gets warmer, it expands in volume. Due to increases in ocean temperature, sea level is also rising due to melting continental glaciers and from ice sheets on both Greenland and Antarctica. Locally, sea levels changes can depend also on other factors such as slowly rising or falling of land, which results in local sea level changes much larger or smaller than the global average. Even small rises in sea level and coastal zones are expected to lead to potentially severe impacts, especially in small island nations and other regions that experience storm surges associated with vigorous weather systems. Why is the climate changing? Climate is always changing. However, the observed changes noted well, I don't let me just see if I can get through this quickly. The rapid change in the past half century is human-induced increases in the amount of atmospheric greenhouse gases, including carbon dioxide, chlorofluorocarbons, methane, and nitrous oxide. Those are all greenhouse gases. The most important of these over the long term is carbon dioxide, CO2, whose concentration in the atmosphere is rising principally as a result of fossil fuel combustion and deforestation. While large amounts of CO2 enter and leave the atmosphere through natural processes, these human activities are increasing the total amount in the air and in the oceans. As an aside here, the oceans are picking up more carbon dioxide. Carbon dioxide dissolves in ocean water. So now the carbon dioxide is going into the oceans, not just to the atmosphere. Approximately half of all CO2 put into the atmosphere through human activity in the past 250 years has been taken up by the oceans, what I just said. The terrestrial biosphere, with the other half remaining in the atmosphere. So half of the carbon that we put into the atmosphere remains in the atmosphere. Since long-term measurements began in 1950, the atmospheric CO2 concentration has been increasing at a rate much faster than at any time in the last 800,000 years. Having been introduced into the atmosphere, it will take thousands of years for the majority of the added CO2 to be removed by natural processes, and will remain for thousands of subsequent years, unless, this is another side, unless we develop some sort of carbon removal system, which we're going to have to, I think we're going to have to do that. I don't know how we're going to, some people are working on carbon, what do they call it? Carbon removal, they have a term for it. It's carbon renewal, carbon sequestration, I'm not sure what they call it. Let's see, they're talking about aerosols affecting the climate. Aerosols are particles in the atmosphere that we put up there. Dust, salt, sulfates, blah, 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 blah. You know, I've gone over this so many times, I'm tired of going over it. This is the American Meteorological Society. So this is not Al Gore, it's not communists, it's not Chinese, it's not George Soros, it's not Black Lives Matter, it's not Mexican immigrants that wrote this, it's the American Meteorological Society. So we can keep going. Actually, what I recommend you do is you type in American Meteorological Society statement on climate change. And you could read this whole thing for yourself. Let's see here. How can the climate change be projected into the future? They're going to talk about models. And let's see. Well, if we keep putting carbon into the atmosphere, it's going to get worse, right? Because every time we burn stuff, every time we take a car, every time we take a bus, every time we take a train or a jet, and we use electricity, we're putting in more carbon in the atmosphere. Okay, because we get all those things by carbon fossil fuels. Do they have a projection? No, they don't have one. Here, let's see. Hurricanes are going to get worse. There's going to get more big rain events. Droughts are going to get worse. Evaporation water or evaporation of soil moisture is going to increase. Let's see. How is the climate expected to change in the future? Just going to get hotter, right? It's going to get warmer. We're going to have more droughts and more big flooding events, and the sea level is going to continue to rise. There'll be more melting of glaciers, and there'll be more melting of the Greenland ice sheet and the Antarctic ice sheet. Let's see, what else? Atmospheric content. The atmosphere will hold more moisture because it's warmer. Weather patterns are going to change. El Nino and La Nina. I don't know if they completely understand I don't think they completely understand how El Nino and La Nina events occur, but El Nino events make it even worse. Final remarks. There is unequivocal evidence that the Earth's lower atmosphere, ocean, and land surface are warming. Sea level is rising. Snow cover, mountain glaciers, and Arctic sea ice is shrinking. The dominant cause of this warming since the 1950s is human activities. There isn't any doubt. There's no argument anymore about that. There's just none. Let's see. This scientific finding is based on a large and persuasive body of research. Even larger temperature increases will occur as greenhouse gases continue to accumulate in the atmosphere. Avoiding this future warming will require a large and rapid reduction in global greenhouse gas emissions. Let's see, technological, economic. Let's see. Prudence dictates extreme care in accounting for our relationship with the only planet known capable of sustaining life. So, like Elon Musk keeps talking about going to Mars. If you could get to Mars, if you could actually get to Mars, which I don't think a human could make it to Mars. It takes years to get to Mars. And then you get there and there's no water and there's no oxygen, on Mars. So, but okay, so shall I go, is this like beating, okay, this is the bottom of the page. AMS is the American Meteorological Society. All this stuff was known almost 50 years ago. All this stuff was known 50 years ago and predicted 50 years ago or 40 years ago. So we've known this for quite some time. Climate is changing. Okay, yeah, I'm not a good reader, and it would take me 10 more minutes to read everything out of that. But you go. It's American Meteorological, here, I can even move it over. American Meteorological Society, right there is the org, American Meteorological Society. Climate change statement. You don't believe me? Go to the American Meteorological Society website. That's to you, Rank. Listen, Rank and Tim Collins. You guys are real lazy, right? And you don't like to research stuff? So what I suggest you do, if you don't believe me, then go to the American Meteorological Society and read their statement on climate change, and you call them liars, and you yell at them and say it's a hoax. It's a Chinese hoax. It's a hoax by George Soros. It's a hoax by Black Lives Matter. It's a hoax by Antifa. Whatever stupid thing comes to your head, right? Because that's what you guys do on the radio all the time. So there it is. American Meteorological Society, climate change.
Your voice, your community.